Hello and welcome to the presentation for our ES50 final project, the Rotary locker system. The intent of this project is to maximize the ability to take advantage of storage space, whether it be vertical or further behind a wall where it typically cannot be accessed. And we do this by implementing a rotary wheel to take things from behind or above or below and put them at a level which is perfectly accessible for normal people. And this model is a little bit smaller. It's a prototype for our creation, and it has 4 buckets, each of which are accessible by a single person with a single password, which is inputted through these switches here. You're able to select which box you'd like to go to using these pressure sensors right here. And as you can see, the door will open if the correct password corresponding to the door is inputted. So as you can see, for this one, it was on, off, on for door number 1. And we have them written down here on this cheat sheet right here. So potential applications for this device could be in, as we previously talked about, in places where more storage is needed. And an example of this is in post office systems like PO boxes, where multiple people need to access mail. And another could be in Amazon workplaces, such as in warehouses where space is also still an issue. Yeah, and let's just zoom right into the circuitry here. As you can see, there is a system of switches implemented and pressure sensors, as well as this red LED that turns on when this door is open, and that is to signify that the wheel will not turn. And the reason behind that is so that Amazon workers or whoever's working in the warehouse wouldn't get their arm trapped as the wheel starts to turn again while it's open up to the certain compartment, or in the more PO box oriented space, that people won't be able to take other people's things by implementing their own password and then pressing another sensor to toggle to a different box. Everything here is sustainably resourced from the Matthews locker. Matthews basement, yeah. And yeah, it's a very green engineering prototype project, and we hope that you enjoy. Yeah, here's my partner John, and
Adler.
Yeah, this is me, Adler. Yeah. Thank you for listening. Hey, ladies and gentlemen, looks like we have a little bit more time, so we're going to be talking a little bit about some of these engineering principles that you see displayed and labeled over here. This is our circuit diagram for our project, and it's pretty nice, so we're going to show it off a little bit. Starting over here, the engineering principle that we used was what we covered in the beginning of the year. Just a little bit of LED resistor action, measuring currents through, turning it on, turning it off, stuff like that. And we paired that with a very simple, basically turn on LED, turn off LED, using this little pin 1 for the Arduino. And this red LED, as we mentioned in the video, will turn on when the wheel is unable to turn. And we just thought it was something that could be nice to add, just a little homage to the earlier days of ES50, which is heavily contrasted to what's over here, which is a and/or gate, basically, that uses logic-based equation or expressions to determine whether or not a requirement for an input is met to give a set output. And specifically, this Arduino is deciding whether or not the combination of ons and offs, as well as the current state of the system, so if it's on, say, door 1 or compartment 1, we need on, off, on. So if it's compartment 1 and this one is on, this one is off, and this one is on, then it will open. And that's a principle that we learn a little bit later in the year in ES50. And yeah, we also have a couple just plain old electrical knowledge checks over here. So if you know how to properly implement, properly assign resistors to, properly wire these servos, yeah, and this voltage divider as well that kind of establishes 2 rails is another neat property that we use in engineering.